3D modeling and animation in marketing. Many businesses and brands in the modern era make use of 3D animation and modeling in their advertising and marketing. This includes mascots, logo animations, and even just memorable CGI effects in their adverts. Audible uses CGI animations to create an imaginative feel in their advertisements, implying that the viewer can immerse themselves in other worlds when listening to their audiobooks. Nike uses optical illusions and bouncy animations to create an abstract and memorable viewing experience in this billboard advertisement. 3D animation and modeling can also help with visualizing the purpose and design of a product by virtually placing the product in the consumer's hands. This allows the consumer to preview and observe the product in detail before purchasing. Using 3D models like this can greatly increase customer engagement due to the interactivity. It's also cost-effective. The creation of the models can have high upfront costs, but their versatile nature allows them to be reused in many advertisements. BMW uses models of their vehicles in online advertising to allow consumers to view, rotate, and customize them in real time. IKEA has their own similar method, allowing customers to arrange virtual furniture in the context of a 3D room. The level of flexibility and engagement present in 3D advertising is miles ahead of 2D designs. As this is still a new and exciting marketing method, many brands are jumping on the trend in hopes of getting ahead of their competitors. 3D models for aerospace. 3D models are highly useful even within the aerospace industry and are consistently used for the manufacturing of parts. Reasons for this are vast, but to list a few, there is enhanced quality when it comes to the parts, as the 3D models have such fine accuracy to allow for even the smallest adjustments to be made precisely. This in turn allows for a reduction in both waste and costs, as if there are more accurate parts that don't need to be replaced due to errors, money, time, and resources are saved, thus making 3D models of this nature imperative to aerospace component production. At the design stage, 3D comes in the form of conceptual modeling, including sophisticated scale models. For prototyping, there is a wide use of 3D technology throughout the aerospace industry. This can range from full-scale enclosures to concept models. 3D printing is revolutionizing aircraft production. It enables the rapid, on-demand manufacture of components and helps to reduce production costs while enhancing aircraft performance. 3D models of spacecraft can also be used in conjunction with 3D printing to allow for smaller scale models of spacecrafts to be produced and tested upon to further optimize the shape and form of the crafts. Or alternatively, surrogate parts that are not integral to function can also be produced for realistic yet cheap tests. Overall, the time, money, resources, and efficiency that 3D models have brought to this industry is invaluable, as is its influence within other industries and environments. 3D modeling in geology and mining. 3D modeling is used in geological studies and the mining industry to visualize a part of the world that is invisible, beneath the surface. The idea of creating models of the geological conditions underground is an old one, with the early pioneer Thomas Sopwith creating models in 1841 which showed the different mineral veins with different types of wood. But the process became considerably easier with the use of computers, and some early experiments in the use of 3D modeling software began between the 1950s and 70s. Initially, such models were restricted to wire meshes, but as processing power improved, solid models became preferred, so that different rocks and materials could be stacked and color-coded. The applications of such models are varied. They can aid in the location of resources for extraction, including minerals, metals, fossil fuels, and geothermal energy. Scientists can model tectonic activity and the flow of groundwater, increasing their understanding of Earth's structure, and governments can use models to inform planning decisions on building developments. Modeling also helps us understand the history of mining by converting old maps and diagrams of now abandoned mines into 3D models, such as those created by Dr. Keith Russ exploring the mines of Cornwall. 3D modeling has therefore been transformative for the geological and mining sector to commercial, scientific, and social benefit. The world underground could not ever be fully understood in two-dimensional drawings, and digital 3D models allow all the fine detail to be produced and explored without the limitations of physical materials. 3D modeling in the automotive industry. 3D modeling is a massive part of the automotive industry. For example, 3D scanning can create accurate models of existing parts, which can be used to test modern design ideas in realistic simulations. This allows designers to explore ideas and move into prototyping with confidence quickly. 3D printing can quickly create prototypes of parts and assemblies, from interior elements to scale models of the entire car. This allows companies to turn ideas into proofs of concept and then advance them to high-fidelity prototypes. This helps automobile engineers visualize and evaluate several factors of the car during development, Thus, apart from no hefty production costs spent on numerous physical prototype creations, 3D printed automotive models are also helpful in identifying potential design flaws. Being able to visualize individual parts is a massive cost cutter when it comes to designing cars. Instead of needing to make specific parts and test them, engineers can simply use 3D software to test compatible parts and even run stress tests. 3D is used when creating concept cars. The designers are able to tweak and change the cars visually and bring their creations to life with ease. By using a library of professionally modeled parts, it becomes an almost drag and drop interface that can save time massively. 3D modeling is a massive part of the automotive industry in almost every stage. 3D modeling in the healthcare industry. There are many ways that the healthcare industry uses 3D models, ranging from getting a precise diagnosis to the planning and simulations of surgery. Looking more into precision diagnosis, there are quite a few different methods of 3D models being used in just this section. For example, in the field of radiology, 3D models reconstructed from medical imaging scans, such as CT or MRI scans, provide a 360 view of what is going on inside the human body. The amount of detail these methods produce can make a huge difference in catching diseases early, and it also assists surgeons in planning minimally invasive procedures. Another use of 3D models in the healthcare industry is custom implants and prosthetics. By the use of 3D models, the healthcare industry is now able to create custom implants and prosthetic devices designed to individual patients. These personalized solutions improve the fit and functionality of medical devices, leading to better patient outcomes and quality of life. Dentistry also uses 3D models quite frequently. Orthodontists use 3D models for all sorts. For example, treatment planning. Dental labs use 3D models to design crowns, bridges, and even custom dental implants. By using 3D models, the patients experience improved dental care and less uncomfortable procedures. Orthodontists also benefit significantly from 3D imaging. Custom-made aligners, such as those used in clear aligner therapy, rely on precise 3D models of the patient's teeth. These aligners are designed to fit perfectly and move teeth gradually into their desired positions. 3D modeling in scientific research. There are many industries that 3D modeling is used. However, one of the most essential and important ones is for scientific research. 3D modeling is used to create visual concepts of different scientific objects, for example, human anatomy. This is useful since it gives people a visual representation of what they are learning, which helps people learn and understand the topic much quicker. In addition to this, since it's 3D, people can gain a much deeper understanding of how something looks and works since they can turn the object around and see different angles of it. Another common way 3D models are used in scientific research is for simulations. 3D objects can be used inside of a virtual world where doctors and trainees can experience doing surgeries or learning how different tools work in a calm, stress-free environment. This gives them confidence in the future since when it comes to live surgeries, they know what to do and what things might look like. Virtual reality simulations for science also save resources, since all you need is a VR headset and a computer, instead of buying equipment that you will have to constantly replace for practice. 3D modeling in filmmaking. 3D modeling in the film industry is used extensively through pre- and post-production. It's used highly in animating nowadays as it allows for a greater degree of realism, and it's much easier to employ complex high-poly models. Another great advantage of using 3D is that it enhances the quality of special effects that would be nearly impossible to achieve with 2D animations. Films such as The Avengers, Toy Story, and Avatar heavily delve into 3D modeling/animation. CGI, computer-generated imagery, is one of the most essential tools in the film industry. CGI is used to create realistic simulated effects that would otherwise be expensive, time-consuming, or impossible to develop in the real world. It allows filmmakers to mimic realistic environments, characters, or even a different world. CGI assists further in the development of creatures, robots, and explosions that are highly used in the action genre. Pre-visualization plays a pivotal role in the filmmaking industry as it serves as an important step, allowing filmmakers to plan and create a basic prototype of the film before shooting begins. The process involves using 3D modeling to create a 3D representation of the entire process, to test out ideas and theories, and to see what remains and what needs to be changed. It helps filmmakers gain a better understanding of the script and production process. The benefits of this help to save time and money as they are able to provide a more efficient way to plan and create the film. 3D modeling in architecture. The use of 3D in architecture applies to a broad range of different sectors. The modeling in 3D can allow architects to easily visualize and plan so that they can easily present to their clients. Using modeling, they can allow clients to see textures and materials. With so many advantages to 3D, visual artists can convert 2D designs into photorealistic renderings of lighting, furniture, and spatial relationships. This helps the architects to better communicate ideas and see their own design flaws. It can also be used for presentation purposes, not only 3D renders, but animations and VR. These can be used in presentations to bring the renders to life. 3D modeling in architecture has become a crucial role in creating compelling design experiences. It provides a realistic representation of architectural spaces, enhancing the design process and allowing for better communication. This enables architects and clients to interact with the design before construction, leading to more informed decisions and successful outcomes. The first 3D game was Maze War, developed in 1973, which introduced players to a first-person perspective, navigating through a simplistic 3D maze. This game allowed movement in multiple directions, which was a novel concept at the time. Shortly after, in 1974, Space Sim provided a more expansive 3D space, presenting players with a rudimentary 3D universe where they could pilot spaceships in real time and combat against other players, all across a primitive networked system. Evidently, this era faced significant limitations due to early hardware and software constraints. Pole Position, released in 1982, was one of the first racing games to utilize a 3D perspective, offering players a behind-the-car camera view that simulated real-life racing far more effectively than any of its predecessors. The 1990s saw a major shift in gaming with the introduction of 3D consoles and arcades. Leading this change were the Sega Genesis and Super Nintendo, crucial in bringing 3D gaming to a wider audience. Despite their initial lack of 3D modeling skills, developers used their power to create early 3D gaming experiences, setting the stage for future advancements. 3ds Max is a widely used 3D modeling and animation software favored by animators for its versatility and robust tools. Renowned studios like Blur Studio and Ubisoft have utilized 3ds Max to create highly detailed animations for video games, films, and advertisements. The software's real-time rendering, advanced rigging tools, and efficient particle systems make it a go-to choice for creating seamless animations. For animators working in 3ds Max, preparation is key to a smooth workflow. Starting with a well-organized scene, including clean hierarchies and properly labeled objects, ensures better control during the animation process. Using layers and keeping meshes optimized reduces lag and enhances performance during rendering. When creating cutscenes that depict mining activities in a mine, animators in 3ds Max benefit from its ability to simulate realistic environments and intricate details. The software's particle systems can simulate dust, falling debris, or flying sparks, adding authenticity to the mining. Tools like PhysX and Mass Effect simulate the physics of collapsing walls or tools striking rocks, creating a believable sense of interaction. To ensure smooth production, animators often storyboard their scenes and use motion capture or keyframe animation to bring their characters to life. For mining cutscenes, precise lighting setups play a crucial role in capturing the dark, shadowy atmosphere of mines. Animators can use volumetric lighting and texture maps to simulate the gritty underground environment.